Climate change is the existential crisis of our times, caused by exponentially increasing carbon emissions. The building and construction sector accounts for over 30% of these emissions while facing multiple challenges such as resource scarcity, inflated construction costs, and supply chain sovereignty. This design presents a possible solution to these challenges through off-site manufacturing and modular assembly. Wajimap is an island located west of Perth and is accessible through ferries. Bicycles are the main mode of transport here. The two sites and the barge from where the modules will be picked up are located within 1 kilometer of each other. The first site is the existing pedal and flipper, the largest bike hire facility in the southern hemisphere. The second site is on the beachfront with unobstructed water views on its eastern boundary. The project is designed on the premise of DFMA, designed for manufacture and assembly. Both residential units and commercial bike storage can be easily disassembled and reconfigured on another site with services. Commercial bike hire facility design improves the bike procuring process's efficiency by reducing the customer's average handle time. Residential apartments are based on a key design principle of providing direct sunlight for more than 4 hours to all apartment units during winter. Dining and living areas have openings on 2 walls to encourage cross-ventilation. Social gatherings are encouraged through landscape terraces, a community hall with a pantry, and communal laundry. Active transport is encouraged with easy access to bike parking. The entire project has been conceived with prefabricated and modular components. The main module size of 10 meters into 4.5 meters into 3.9 meters can be fit out and be used for both bike storage and accommodation requirements. The base module can be split into smaller modules by partial removal of columns and beams. The units are derived from a combination of module types A, B, and C. Type A hall module contains the living, dining, and kitchen area and is common for all apartment unit types. The base module is fit out differently to fit the bedroom and bathrooms as required for the design. The first site is planned with fenestration openings towards east and west, and the second site is planned with fenestration openings towards north and east. These orientations optimize sunlight and nature views. The mixed-use project on the first site includes commercial and residential functions. The commercial bike hire facility is located on the ground and first floor, and the residential apartment units are placed on the second and third floors. The habitable spaces are planned along a linear atrium with vertical circulation core situated in middle zone for building compliance for Class 3 and Class 6 buildings. The commercial component includes bike storage, reception, cafe, and administrative functions. The residential component comprises 3-bedroom, 2-bedroom, and 1-bedroom units. Community-based facilities such as communal laundry, landscape terraces, and bike parking are also provided. Natural and cross-ventilated areas receive ample natural light and lessen the need for mechanical systems. The weathered steel facade is abstracted from local topographical elements found at Rottnest Island such as waterways and nests. The white fiber cement cladding reflects the white sand beaches of Rottnest Island. Solar shading devices such as perforated screens, vertical louvres, and second skin facade systems reduce the solar heat gain coefficient of the building and increase its energy efficiency. These elements create visually appealing shadows in the interior spaces. The circulation core located in the central zones allow for vertical movement of the residents and separates the zone from the commercial activities. The apartment interiors are warm and inviting, with dining and living areas having openings on 2 walls to encourage cross-ventilation. The commercial and residential corridors are visually connected through the atrium. The perforated screen shields the sunlight coming in from the solar glass skylight and creates circular shadows in the atrium spaces. The mixed-use building on Site 1 is constructed through a hybrid system of modular and prefabricated manufacturing systems which are carbon neutral and have low embodied energy. Mass timber modular apartments and bike storage are linked through prefabricated Glulam columns and beams in the transitional spaces. The vertical circulation core is assembled through prefabricated fly ash concrete panels. Similarly, the double height structure in the front is assembled from recycled steel columns and beams. The individual module is assembled from Glulam columns and beams with cross-laminated timber floors and walls. Wood fibre insulation is used to separate the claddings from CLT wall panel, and fire-check plasterboard provides additional protection from fire. Space for services is provided above the false ceiling and underneath the floor, while the vertical services movement between modules happens through the service ducts. Columns are interconnected through steel dowels, while column to beam connections take place through concealed steel knife plates. This allows for flexibility in design as modules can be made bigger or smaller through partial removal of beams and columns. The design considers the existential crisis of climate change and addresses it through innovative mitigation technologies and net zero materials that can be used in addition to sustainable construction techniques. This approach overlaps with indigenous design principles of caring for country. These principles include generating energy through renewable sources, using durable and recyclable cladding, integrating vegetable gardens and water feature, and reduce solar heat gain through the building envelope. These sustainable design features are discussed in detail in the concept validation report.